the cities are facing a lot of challenges, and I'm not going to go too much into detail about what we are facing because we already know. Like we know, the urban population is going to be by like around 68% by 2050, and that's going to bring more and more resource scarcity, extreme weather events, heat island effects, etc., etc. But then we have to start thinking, what are the solutions? And what are the actual solutions? Like, do we need more smart cities? And from, what we know, like, we don't. Or, like, I'm not 100% sure, because what we have learned so far is that while some of them do work, but then there are a lot of cases where we actually find out that they don't really work very well. For example, we know the case of the sidewalk labs, the Songdo district in Korea, and we know they were really smart, but what they were missing was the human touch, the human values they were missing, and that's why they didn't work out well. And that kind of brings us to the next point, which is, God, that why do we have to rethink about these cities in a way, whether we need them, like the smart cities, or what's the role of the ICT in that? So if you look at the projection for 2025, we produce almost near about 200 zettabytes of data, which is quite a lot of data, almost 200 billion terabytes of data. And this data somehow goes within the cities. So cities are like these digital landfills where the data goes and somehow disappears, because if, imagine, we were really using this kind of data, we would have solved a lot of pressing issues by now. But as we know, there are still a lot of them remaining. And quite a few of them are the ones which are very critical. And the one which I do focus in my area of research is air pollution, which is both indoor and outdoor. So it is one of the problem and challenges where it's not just dependent on us, on the human, because we have to breathe, and we cannot decide when to just stop breathing or not. So like, you are indoors, outdoors, you have to keep breathing, and there's very little control you have on the air you breathe. And one of the key pollutants for air pollution is a PM 2.5, which is even smaller than human hair. It can go inside our respiratory tract and cause a lot of problems, which can be, asthmatic problems, or things like more, issues in elderly as well as the young. Now, let's look at the standards of PM 2.5 at the moment, because we need to understand how much is good and how much is bad. If you look at different standards, so the WHO is the main body which makes these standards. It's almost 5 microgram per metric cube. For European Union, it's 25. For Switzerland, it's 10. It's kind of fascinating that there is one thing which we know, like, it's bad for you. How does it change when you cross border? Because like, the impact is always going to be the same. And like, I tried to look into, like, how do they decide these standards, and found out that it's very different. WHO usually looked at, based on like the health-based standards, looking at the epidemiological studies and things like how much it impacts human health at a general level, whereas for countries like US, European Union, Switzerland, and others, they are based on these policy-based PM standards. And the difference is, for most of the countries and cities, there is this legacy pollution which has been going on for years. So the standards that they set for themselves are kept, like, they always keep in mind that they don't really overpromise, even if it's far away from what is actually good for you or not. So, and it also depends on a lot of urbanization, because, for example, there has been a lot of urbanization since the beginning, so the impact is still there. Like, for example, previous use of fossil fuels, and currently also many countries are still using it. So it's kind of interesting, like, how much we know, how much we don't. Although this is one of my areas of research, but I still kind of struggle to find these documentation where they clearly explain what's the rationale behind these standards. And coming back a little closer to to Switzerland, there was this recent study which found out that there were only 7 countries in the world that matched the WHO standard, and surprisingly, Switzerland was not one of them, although Switzerland is considered to be one of the very cleanest cities. And then there was this recent report that the fireworks release around 400 tons of particulate matter. And you can see this is like a very beautiful view on Lake Zurich of how the fireworks look like. So, like maybe if the people who are not from here, they are planning to come to Zurich to see these fireworks, I would have to disappoint you because this only looks like this on Instagram. In real life, it looks something like this. So the reason behind that is because first of all, it's at night. There is this cold weather, temperature inversion. So most of these pollutants, they stay low. So it kind of creates this smogginess where you can hardly see the fireworks, but you feel like heaviness when you're breathing. So why I'm telling you this is because we know this thing is there, and usually it's the cities, like who should be, or who usually are doing a lot to tackle this problem and make people more aware of this. And in case of Switzerland, there is this network of stations for air quality monitoring. And officially, from the Swiss government, there are these 16 stations. And if you look at the top in Zurich, so there's one at Kaserne as well as one in Dubendorf. These are the stations by the EPA, like the Swiss EPA kind of. And then you, from the city side, there are three more. So in total, you see there are these 5 stations. I have overlaid it with the population of Zurich, so you can see a lot of hotspot are still not where the like the deployment of these stations are. So imagine, like if there are being policies which are tailored for a city, how do they even decide like what should be the limits or what shouldn't be the limits? Because on an average, Zurich's population is around 400,000. So what these sensors cover, and I've been very flexible in keeping a 500-meter buffer. So let's say, like they can catch everything within those 500 meters. So only 10.23%. So while going through this, we were also thinking what we can do as researchers. Also, as I have strong interest in understanding how we can use technology for social good, also looking at open source and DIY tools. We started working on this society framework, which is pronounced as society, like social, open source, and collaborative Internet of Things framework, where we built these low-cost sensors, and the key idea behind them was open source hardware, open source software, and open source data. So we wanted to create a setup where it somehow also promotes this technological citizenship where people can have the means to do things like build their own sensors as well as make more informed choices based on the data. So when we built this thing, like it was quite an interesting process because we also went through the design process a lot. We looked at the idea that a lot of these sensors which you find, or the ones which are conventional sensors, are like black, dark, gives like a feeling of sadness. So we try to add colors to it because also how you use things depend on how you perceive these things. So that was more like a design perspective when we looked at it. Next, we started to look more into how to use this thing for benefit of people. And we, like Rosie mentioned on Tuesday in her talk, we started this process with the Citizen Science Center. It's called Know the Air You Breathe. So the idea was, because most of us spend so much time indoors, do we actually know what we are breathing? And we started with this co-creation process where we wanted to understand why would people actually like to engage in this process, what they would like to know, and how would we go ahead doing it. So usually there are different forms of citizen participation. Like sometimes you just reach out to them when you have to crowdsource data. But in our case, we started right from the initiation part. So before we started describing what we are going to do, we wanted to know what people know, what they don't know, and we gave them a brief idea about, in general, idea about how Zurich is, what are the pollution levels, and I would say 90% of them were surprised because everyone had this perception that Zurich is super clean. It's like a nice wind and air, you know, mountains around, but surprisingly, it was not the case. And with all the knowledge and curiosity of people, we found that people wanted to know more. We also performed this small activity called empathy mapping, where we wanted to understand how do people, like react when they can connect these things directly with themselves. So there was this understanding that they like to create this shared understanding of this different situations so that everyone can connect. When you have different stakeholders, they bring different perspectives to the table. There's knowledge and data exchange. And more importantly, we believe that it kind of leads to emergence over extraction. So we are not really looking for just data, but rather contextual insights. The results were quite interesting. We ran this process for several months. And what we found out was, in general, the input output ratio, which is the ratio between outside pollution and inside pollution, it was much higher than 1, meaning the indoor environment were much polluted than the outdoor one. And we also did like a short survey before we shared the data and after, and it kind of changed drastically. Like in the beginning, almost 80% of people was like, it's good, everything is perfect. And once we showed the data and we asked whether it's likely they're going to take any action, and most of them were like, yes, they would like to know more. And that led to more conversations about accountability, like who is accountable, who should be reached out to, what should people do in case when they know that these things exist. uh, One of the very funny or surprising thing was, a lot of people started asking about what do they pay rents for, because usually, like when you're renting an apartment, there's always a thing about convenience of traveling, like whether you're close to city center, proximity to other locations. But indoor environment or air quality is not something which, like is quite a lot of times highlighted as a factor of deciding the rent. So there was something which was quite interesting for us that led to new discussions and ideas. Then we also looked at other citizen science initiatives all across the world, like mainly focusing on Latin America, Asia, South US, as well as Europe. And we created this conceptual evidence co-creation framework where we try to understand how can we bring the knowledge that we learned from doing real world activities, and as well as what we have learned previously from the different theoretical studies that we have done. And we realized that we need to start in a process with the stakeholder mapping, where we can understand who the key stakeholders are, what they actually want to get out of these activities, and whether there's a way to somehow balance it out so that there's no power imbalance and no one is overshadowing anyone else. Then what kind of tools we can use. And like I mentioned, that our main focus is on open source data. So how we start is, like, before we even use any of these tools, we try to do a co-location or a calibration. For example, in our case, we did it at EMPA. Like, they were kind enough to let us use their facilities for 6 months. So we were testing these low-cost sensors with the high industry-grade instruments. Now, I won't say, that they are 100% accurate or they match well, because these are, let's say, you can make one in 150 francs, and those are like thousands of francs. But the idea was, we wanted to do as much as we can from our side to reduce the issues of errors. Then we also created these open source no code tools where people, if they are interested, they don't have to do any programming, they don't have to be data scientists. They could simply upload their data to have some interesting insights. And then data sharing, having open source protocols, how people can convey this data, creating data stories, such as, so that even when non-experts are communicating this data to experts, they find an easy way. So whenever I'm discussing about these kind of frameworks, a lot of times these questions are asked, like, how do these things work in different contexts? And for us, like, it's quite different, because, like, I have had several experiences of working on similar projects in different places, and you always have to tailor your ideas based on the audience that you're working with. For example, in one of the projects, we designed for curiosity. So what you are seeing is like how a pollution particle looks under a microscope. So the sensor that we developed looked like one, and it was surprising. Like, a lot of people were just, like, they just want to know what it is. So that kind of leads to more conversation. Then people want to know more and they start asking questions. Similarly, in another project in Taiwan, we we started this project called the Airbox project, and in 2015 we had almost like 77, that was the official stations. And it was more like a bottom-up project, a civic tech project, if I would say, where we started working with, not excluding the government, but also with the government and other stakeholders like the maker community, the schools. And by 23, we had almost covered the entire island, and we were using this data to support the policy making, also supporting people in making more informed choices using different applications like chatbots, routing applications, etc. Now, this kind of gives you an idea about how, like, we can use open source data for the cities and making informed choices. But then there's another element of this, like, what else can we do for the cities? And like Vittorio mentioned, when we're looking at the proximity thing in the cities, there's a lot of focus on different elements. And in smart cities, I think one thing which sometimes is missing is how much you can access these recreational facilities or green spaces. If you look at the traditional methods, like there is NDVI, like the canopy cover, green view imaging, and a lot of these processes. And on this side, you can see like it's based on satellite imaging. While this has been a conventional tool to understand urban greenness, there has always been like the resolution factor, because usually these satellite images, the ones which are free, they are, like the resolution is lower. And if you want to really access the expensive one, you have to pay a lot of money. So this was my motivation to work on this framework called Greener Framework, where we wanted to create like a new idea of understanding green index, but looking at the distribution and proximity relative to the street network. So here you can see the street network of City of London, and we try to do it at a micro level as per the edges in the city. And it's a bit dark, but so what we could find was that the results were quite interesting, that you could actually go through like every edge level within a street network to do this thing. Now this whole the Greener framework kind of provides other applications as well, because it's an open source system. So it somehow allows you to do more like dynamic accessibility mapping, understanding how different layers of data can be combined over each other. For example, here you can see, you can, like, I think Vittorio mentioned about using the hexagons. It's a very standard method that we use here. So you can always come up with like population data, socioeconomic data, and try to understand how greenness varies in cities. Now, one thing which I would like to show you, like in Zurich, there are almost 80,000 trees. And when you have these tools, like you can really go deeper to understand where exactly, like to, I would say, wouldn't say centimeter precision, but let's say meter precision to know where these are. Also, you can look at the species, you can look at their heights, you can look at the crown length and everything. Now you'll be asking, but what are we going to do with it? So what we can do is we can create maps like this, which are on the right side. You see, like it's a pollen tree map. Like I'm personally allergic to pollens, so I was understanding, like what can be done, and we found like there are ways you can create these maps which are very localized to understand these hotspots. And I'm not joking, but it really reduced my intake of antihistamine, because now I know which areas I should walk around, which areas should I not. So this is just one example, like how this data can be used. Once we have all these data, we can use them as layers as well on different things. And yesterday, Dirk mentioned that we, together with a lot of people here, we built this platform called Routify, which stands for Route Intelligence for You. So instead of just finding shortest paths or things like that, which are there on traditional route recommendation applications, we used what we have. Like we used open data from OpenStreetMap, the green data from Greener. Swiss government provides the elevation and the noise data, air quality data from IQ Air, TomTom for traffic, and the real-time IoT data directly into these networks. And this is how the current application looks like. It gives you a good idea, like all the routes that you can take, very fine-grained idea about, like the elevation, the air quality. So the idea is, it's not a data-driven application, I would say, because in the end, the result is more informed choices. So you can get to know about what choices you're making. And we're not just trying to optimize, but rather trying to bring in a human perspective where they can actually look at these things and how they're done. So with all these things, I see that, with the smart cities, we have this one trajectory, which goes through technology, bringing predictive analytics, optimization and automation. But I also see this another trajectory, which goes through this part where we bring this open source urbanism, as well as data democracy, predictive analytics, and collective intelligence, that somehow brings these things together, where we have transparency, trust, resilience, and can also lead to more human-centric cities. Now, to finish my presentation, I would like to just show you this thing, and I want to ask, do you know what this is? Does anyone know? Yeah, so this is a very interesting phenomenon that happens in nature, because, Dirk always says we can learn a lot from nature. So I'm just using this as a metaphor. So this is called crown shyness. So if you walk around in a jungle, so it's not everywhere, but there are several species that they never touch, like their crown. So they always create these gaps in them. It looks very pretty. And I think it's still a part of research. I'm not an ecologist, so like it's still like people are trying to understand why it happens. But when I see this, I can also compare it with how we work with the citizens or like the community. That there are individual spaces in there, but also the collective strength is like it's a resilient forest, and it's similar to how we see the cities. So there are these individuals who bring like wealth of knowledge, and when we combine them together, there can be this collective intelligence which comes with people. Then the boundaries are more like opportunities, because when you have these boundaries, it kind of gives you the flexibility to innovate more. So there are more unconventional ideas that allow people to think more independently, freely. And then there's no central authority which is making this happen. This is all emerging from a very different way, very similar to how we do grassroots research, where these ideas are emergent and from a bottom-up perspective. And yeah, I would like to thank you for paying attention.